and welcome everyone. Today we will see how we can create custom VI based periodic IO servers using DSC modules. So first I will tell you why custom VI periodic servers are being used. A custom IO server publishes the selected data items as an publish subscribe protocol data items on the network. So the custom IO server shares ownership of the data with some shared variable engines which publishes the data. So we can create an IO servers, custom IO servers of two types, on the input change IO servers, and the second one is the periodic IO servers. So the create a periodic IO servers when we want to control the update rate of a data items, and when we have a continuous update of the data items, for example the temperatures. So today we will simulate temperature and see how we can basically create a custom based periodic IO server. So for that purpose I will just open a new VI and open my front panel as well as block diagram. On my block diagram I will place express input and simulating signal. In simulating signal I will create a simulate acquisition timing I will set, and I will just add a noise as well, so that it will give me a realistic effect of my signal. Although it is a sine wave, but it will give me a simulating sine wave with some noise of 0.6 amplitude. Now I want to create its upper and lower end, like you can say its higher and lower boundary. So for that purpose I will use a knob and I will say its maximum temperature limit or set, which I can set, and similarly I can just set its lower set point, lower temperature set point, basically set point. So that's how I will change its above name as well, maximum temperature set point. So that's how you can set it up to, might be, let's say 80, and the lower should be, let's say 60. And similarly I can set its lower from to 60, and the minimum value will be, let's say 40. And then I can even change their knob colors. Let's say I set the needle color as red, and I can set the lower temperature set point needle color as blue, so that it looks more appropriate. I can even create their digital display, so that they will give me a proper outlook that how the temperature is being varying. I can change their representation as well by using I32, so that there will be an integer, not some DBL double precision number. I want them integer, like in the form of, right now as you can see, in the form of numbers. So I will just again go on to my block diagram, and then I will choose a negate function, and I will set that the maximum minus minimum divided by 2 will give me, instead of plus I will use divide, so that I will divide it by 2. It will give me the amplitude basically. So I will just connect it with my amplitude, and then now I want to change its offset basically. So for offset purpose I will connect it with I will again use a subtract function. I will connect my maximum, that I will go maximum, and the divide function will be connected at the y point. and then I will connect it with some offset. So that's how you can set its the simulating signal should be within the range of maximum and minimum point. We will see this by using, let's say I want to convert this dynamic data type, convert from dynamic data type. As you can see, the output right now is the 1D array of scalars, but right now I want a single scalar. It means the output will be in the form of single value, which is double. So I will connect it with the dynamic data type output to convert it to DBL form, and then I will use merge signals so that it will show me the three values, basically the maximum, the current temperature, and the minimum ones, and the minimum limit basically. So I will go onto the front panel, and here I will create a chart, and as well as I will create a thermometer which will show me the current value of my temperature right now. So I can create a digital display as well. I will place it in here, and then I will say again go to block diagram, or I can just change some appearance of my chart. I can use white color and go to its properties and select the scales or plot. I can choose the line color as black, and the points that it will make is this, and little bit thicken the I will create the thickness of my line, and then I will choose select none so that the points will bother us and create no function. And my line color right now is black, and it's alright. So again I will go on to my block diagram, and then I will just place it in within the while loop, and I just connect it with my waveform chart, and I can create its control, and I can place it in here and change it, replace with some more good looking silver stop button so that it will look more appropriate. And then I will add just one more thing to predict it more appropriately. I will add a burner in it, or the heater status in it, which will show me if either the heater is on or off. I will place the heater condition in here. Let's say the heater is like this, so I will place it in here. I will go to my front panel block diagram, and then I will again just now I want to set the condition that whether my current temperature is in the limit or not. So I will set that if it is greater than my maximum limit, and similarly if it is less than or equals to my lower limit. So that's how I have right now two conditions. So for that purpose I will use a case selector basically. So I will just make a copy of it, and then again I have to connect these two cases with my one boolean indicator. So for that purpose I will just go to my block diagram, and I will use a false condition, and here I will use a true condition, so that as soon as my temperature goes above the maximum point it should go false, then the heater status should go heater LED will be turned off, and as soon as it goes below the lower temperature set point, then my boolean LED should turn on. So for that purpose I will just connect it in here. Now one tunnel is missing, so I will connect it from here so that it will retain the value that is on the heater. Now I will just add one more thing to control my iterations. So here I will again create a control and show you. Let's say the control value is 200, and I can say its iteration rate, or I can set it in here, and I can also set the data operation make the current values default. So the purpose of the make current values default is whenever you will close your front panel and the whole program and you come back again, this value will be saved in here. Similarly, you can set these values as well. Let's say I will set the value of 70 here, and the lower value is set it to be 40, and then the lower value is set to be 40, and now I can also make their data operations make current values default, so that whenever I will come back, these value will be saved. So that's how I can create the front panel for the simulating temperature. Right now I can run this to make sure that it is working properly or not. Right now my upper and lower values are just stick to the stick with some lower and upper boundaries, so I can just change their thicknesses. Like the red plot, I can change the line style and line width to something more darker, and I will just go to its properties, and for the y-axis scales I can set that. So for y-axis, instead of auto scale, I can set that the minimum is, let's say, 35 and the maximum is 85. So that's how I can set their limits. As you can see, my plot 1 line right now is more darker, so I will just make it more appropriate. So that's how you can simulate the signals basically. Right now this is our temperature value. As you can see, it is going up and it is going down right now. Now we can create a custom VI periodic as well. So for that purpose, I will just create a project, and then I will select a blank project and add it to my project file. I can save that file, save this file to in any of my folder. Right now I can just create a new folder. Let's say a custom periodic VI, and then I can open this and I can place my file in here, as well as my this custom periodic VI with the name of temperature server, and that's how I can save my custom server. And now I want to create the custom periodic VI. For that purpose, you just must have to install the DSC module. For that purpose, if you install the DSC module, then only you can see this IO server basically. So I have already told you why these IO servers are basically used. So right now we will create a custom VI periodic and we will continue it. After continuing, we can select the new and give the path of my current server VI, and for that purpose I will just go to the folder that I created before, and I will go to custom periodic VI, and then I will select the temperature server. So right now I will select this and press on next. It shows me the controls that I have created as well as the indicators. Right now I can deselect it, or I can just go with the already selected items. I will press next. Now I can select the stopping the execution of my server. So how do I want to close the server or stop the server? I will stop the server by using the stop the following while loops. So whenever my while loop is stopped, then the server will be stopped as well. So next function, and next, now we can build this system and we can replace this. since I already built it one custom periodic VI before this tutorial, so that's why it requires to replace the function, otherwise that will be no issue for you. So that's how I have created a custom VI periodic. I can save this file as well, so that's how it is shown. Now I will create a client VI. So for that purpose I will go to new and create a VI. So in this VI, this will be our custom this will be our temperature client VI basically. So right now I want to show my chart in here, and again I can go to its properties, and I can, for its y-axis, instead of its auto scale, I can select 85 as 35 and 85 as maximum. I can select it, and then to show my heater indicator, I will select the heater status. I can just I can resize it, and then I will show my maximum and minimum values, maximum set point, and similarly I can choose minimum set point, and also I will show the loop iteration rate. So for that purpose I will create another indicator, iteration rate basically. I can rename it iteration. So iteration rate, I can now align those things in here so that it will look more appropriate to me. So I will go to block diagram, and now I can create a while loop around here. So how do we communicate with our client and server VI basically? So for that purpose I will just go on to my server again, and then again one by one I will create shared variables here. I will create new shared variable, and similarly now I will go to my project file. As you can see, maximum temperature set point is being created. So that's how one shared variable is created. So again I will go and create my another shared variable, and similarly I will create all the shared variables, create the new shared variable, and again create the new shared variable, as well as for the heater status create the shared variable. I can go to shared variable property node, and I will create the shared variable, as well as for my iteration rate I will go and create new shared variable. I can also create the shared variable in here, shared variable, new shared variable. So that's how all the shared variables are created. As you can see, it created once I created the shared variables with its own libraries, but we can select it and drag it to all these shared variables within the within one library basically. So all the shared variables are dragged in here. There is no problem with some with the ascending or descending order. Wherever they are placed, they can be randomly placed, so there will be no problem. We can remove those unwanted libraries from here like this, and then after removing all those libraries that are empty basically, we don't need those libraries, I will open again the client VI, and I can place all those shared variables in here so that they will show me the maximum temperature set point. And again I will go to my front panel, I will place a silver numeric and the temperature indicator of the current temperature basically. So that's how if I go and create a digital display I can. And then I will go to block diagram and I will attach one by one to these. So for maximum set point, as you can see, the maximum set point is given in here, and for the lower set point, minimum set point is given in here. The waveform chart will be connected to the waveform chart, and the thermometer will be connected with my current temperature value, and the stop condition can be attached with my abort execution or the loop condition basically. And the heater status will be connected with my heater shared variable, and the iteration rate can be selected attached with this iteration rate right now. So that's how it is created. Now I will just go on to my front panel of the server and just clean it here so that it will give me a proper look. I can just drag it to scale down so that it will give me more appropriate look, as well as I will just go and check this. I will open these windows side by side so that they will give me a proper idea of whether they are working right or not. So this is our basically our server vi, basically our client vi. I will put all these things in here so that they can be seen side by side. And similarly, this is our this server vi. I will place the iteration in here so that I can see whether it is working properly or not. So I will run this vi and run this vi as well. So as you can see, both of these values right now are same, and that's how the server vi is being generated. So as soon as it goes below, the heater status is on, and heater status is on in here as well. So now if I want to stop my server vi, I can just close it from this stop function. If I close this, my windows are my VIs are also stopped, as well as my server is also stopped. So we can just save this server, as well as I can just save all those libraries. So that's how we create a shared variable. I hope you will like my video, and I hope you will subscribe my channel and appreciate my work.